Math 140. Week 7, topic of the week is normal distributions, also known as the bell curve. We got 3 videos coming this week. Let's check out part 1. First problem in the homework. If I'm asking you about discrete variables and continuous variables, before you answer these problems on the homework, I want to make sure you understand this distinction, discrete and continuous, based on these 2 problems, made-up problems here. So the first made-up problem is, how much eggs do you have in a recipe? Second one is, how much milk do you have in a recipe? Which one of those is discrete, which is continuous? Well, let's make sure we know the definitions. If I am talking about discrete variables, discrete is, here's a silly analogy. If you ask a 3rd grader about a number, they're going to say 1, 2, 3, 4, 5, 6. That's discrete numbers, like 3rd grade level numbers. If I'm talking about continuous, like I don't need to talk to 11th grader in high school, they're going to say decimals, fractions, maybe even something like pi, numbers that go on forever. Those sort of numbers, we're dealing with continuous. If you keep those distinctions in mind, I think you know if we're talking about eggs, you add eggs 1, 2, 3 at a time. Discrete. Milk in a recipe, sure, you can put in a half cup. That's continuous. Understand the distinction and apply it back to the examples I gave you in the homework, but I think you can see what's going on here. However, the real main event for this homework, I said, is normal distribution bell curve. Problem number 2 deals with this sort of thing. So you're going to be asked about z-scores, probabilities, drawing sketches. You'll do it with these ones. I'm switching the numbers, but think of all those different pieces. Z-scores, sketches, probability. A lot of stuff going on. Let's take it one at a time. If I'm talking about a sketch, I'm going to draw this. Like I said, normal distribution or bell curve. And I think you can see how it's a bell. A lot of people say, well, what's up with these numbers? They're the z values. People say, why 1, 2, 3? Why doesn't it go 10, 20, 30? Here's I never like to say this as a teacher, but I'll just tell you this. That's how z-scores work. 1, 2, 3 up. -1, -2, -3 down. That's how z-scores work. So what we need to do is we need to somehow connect z values in this sketch to probabilities. Or remember last homework, probabilities mean percent. So let's look in here. If I'm saying z is bigger than -1.85, okay, first thing I'm going to do is I'm going to identify where that number is. -1.85. It's like about there. How come I know it's there? Remember what I did. First thing I did is I labeled 1, 2, 3 up, -1, -2, -3 down, so we can figure out where the -1.85 is. What's next? This says bigger than. So what's that mean? I have to color in my graph. I'm going to color in the bigger side like that. And really what's going on now is when I say probability, P or probability, another way to think of probability is percentage. So if I'm bigger than that line, what percentage of my graph is colored in? All right, we could even guess right now. I'd say, well, that's a lot of it. Maybe 80% of it's colored in, maybe 90%. I don't know, something like that. But we want to be a little more precise. And this graph or this chart, which should be linked on Blackboard or in your homework in Acrobatic, gives you all the percentages precisely. Remember, I guessed maybe about 80% is 80% is colored in there. This chart will give us the exact answer. How? Well, remember, I have the z number that was from the problem. And I know it's negative, so I'm going to look over on this side of the chart. And I say, okay, -1.8, you see right over here. And 1.85. Okay, 5's up here, so I crisscross. Hey, right there. I got an answer. This chart gave me an exact answer, right? Okay, I'm feeling good. And I can write it as percent, 3%, so I'm done, right? No problem. Just use the chart, and I get the answer. Well, careful. Remember, we want it bigger than. And so if I'm looking at that picture right there, 3% is bigger than that. I was saying like 80% or 90%. That doesn't make any sense. So what do we have to do? Look at this chart on the bottom. It tells me, hey, wait a minute. This percentage, that 3% we solved, is to the left. So in other words, that 3% I found from the chart is on this side of the graph. That's 3%. How do we get the number that I want, the bigger part? Well, if you put them together, it has to be 100%. So why don't we just subtract it away from 100? If this green part is 3%, which I found on the chart, this has to be what's left over. So I take 100 minus that 3%. I'll let you use that. I'll let you solve that subtraction right here, and you can find this bigger than percentage. And then in our next video, remember there's 3 videos coming this week, we'll solve part B and some other ones. Stay tuned.